Get all these common multiples. So we prime factorize. Can you go any further with 2? It is a prime number, so it's just 2. 6. What two prime numbers can we break it down into? 2 times 3. And 15. What two prime numbers can we break it down to? 3 times 5. So in lowest common multiple, we had to take the highest power of each prime. So we look, okay, 2. What's the highest power of 2? 2. What's the highest power of 3? Just 3 is the power of 1. And then 5. Highest power of 5 is 5. So highest power of each prime. Sometimes it's 2 squared or 3 squared, right? But this one, they all had just power of 1. Okay, so 2 times 3 times 5 would be 30. That would be the lowest common multiple. So that means, does 15 go into 30? Yeah. Does 6 go into 30? Yeah. And does 2 go into 30? Yeah. It's the smallest number that they all divide into. That's the lowest common multiple. Greatest common factor. We are going to actually skip the tile part, the algebra tile part. So actually, let's turn the page. Okay? So we're going to get into factoring. So this is the first step in factoring. Every time we factor, we have to pull out the greatest common factor. That's always our first step. If there's a common factor, it must be pulled out. So what is factoring? Factoring is opposite of distributive law. Completely opposite. So when you are normally trying to expand, we're going to do opposite. We want to put them into brackets. Pull out something that can be multiplied by each number. So to factor is to express a number. To express a number or expression. What's an expression? It's like an equation, except for
it doesn't have equals, greater than, or less than sign.
It doesn't have an equal, less than, or greater than sign. Very good. Okay, so its expression has variables. It's just like an equation, except for technically it wouldn't have an equal sign. So like 3x squared plus 2 is an expression. Okay? As a product of its factors. Express an expression, yeah. As a product of its factors. So for example, if we go very, very, very basic, 30, we could factor it by expressing it as 2 times 15. Okay, is there other ways we could factor 30? 3 times 10. Yeah, there's other ways we can actually express it. So it's the opposite of distributive law. It's the opposite of multiplication in a way. So we're kind of using division here. Kind of, you'll see. Does everyone remember what a greatest common factor for a polynomial? Well, what's the greatest common factor? When we found greatest common factor, what were we looking for when we prime factorized? The largest number they have in common. So for polynomial, this is what it is. It's the largest monomial that is a factor So when it's a factor, it means it'll divide into it. Right? Will 30 divide in, or 15 divide into 30? Yes. Will 2 divide into 30? Yes. So when it's a factor, it'll divide into that original expression. So that is a factor of each term. Greatest common factor must be a factor for every term in the polynomial. Okay? So when we want to factor out the GCF, for a polynomial, we're going to divide each term by the GCF. Then the polynomial can be written in simpler form. So by looking at this, 2 and 10, what's the largest coefficient or number that will divide into 2 and 10? 2, okay? So that one's obvious. Would we need to make a factor tree to see that GCF? No. How about x squared and x? What's the largest I can divide into both? X. X. The largest in common is x. Right? This has two x's, this has one x, so they each have at least one x in common. Because we could write 2x squared as 2 times x times x. Right? We can write 10x as 10x. So what's in common? They have one x in common. Do you see that? It is. It is 2 and x. The largest monomial we can divide both of those by is 2x. So we're going to actually factor out the 2x. We're changing it into multiplication. Okay? We want to pull out 2x from both of them. So how do we do that? Well, to figure out what's left in the brackets, we're going to divide each by that GCF. So what's 2x squared divided by 2x? Yeah, x guys, stay with me. I know this is tough. 10x divided by 2x would be 5. So now we did the opposite. We pulled out the greatest common factor. How could you check your answer? Expand it? Could we not just expand it to see if it gives us our original expression? Does 2x times x give you 2x squared? Yeah. Does 2x times 5 give you 10x? Yeah, we can just go backwards to check our answer. Okay, you could use prime factorization to figure out your GCF. You don't have to. We could. So let's prime factorize 18. How do we do that? Okay, so 18, what's the first prime we can divide that by? 2 is 9, then you could divide it by 3 is 3. So we can write 18 xy squared as 2 times 3 times 3 times x and times 2 y's. That's y squared. That would be prime factorized. Yeah. Or 2 times 3 squared times x times y squared. Yeah. Okay, 27. Let's prime factorize that. Yeah, we're looking for the GCF. We're not done. This is just the prime factorized form. Okay? 27, we can divide that by 3 is 9, 3 is 3. So 3 times 3 times 3. And then how many x's do we have? 3 x's and 2 y's. We're looking for the greatest common factor. So greatest common factor, when we prime factorized, we're looking for what's in common. So what do they have in common? 2, how many 3's in common? 2 3's and 1 x and 2 y's. So you could use prime factorization. So what would that be then? The GCF would be 3 times 3 is 9, x, y squared. So we want what's in common. They both have 2 3's. They have 1 x in common and 2 y's in common.
How do you get the squared though?
How do I get the squared? Because they have 2 y's, y squared.
Then why wouldn't it also be 3?
Oh, well, 3 times 3 is 9. Yeah, 3 squared would be 9. Okay? Okay, so that's using prime factorization. You probably won't use that method. It's probably easier just to make a factor tree to find the greatest common factor. So let me show you an example with a factor tree. Turn the page. If we're simplifying, yeah. So this one we're just looking for the GCF. It wasn't asking us to factor it. If it says factor, then we're actually going to pull out the GCF. Okay, so here we go. So looking at this, I'm going to show you using, instead of prime factorization, let's use just a factor tree. So how can you write 6?
2 times 3.
Okay, 2 times 3 or
3 times 2.
1 times 6. So not using prime numbers, just their factors. 24. Start with 1 times 24. 2 times 12. 3 times 8. 4 times 6. And 12.
2 times 6.
2 times 6, 3 times
4.
4, 1 times 12. So that's okay if it's negative. So we're just going to look at the coefficients without the sign. So what's the greatest factor they have in common? The largest number they have in common?
6.
Yeah, the greatest factor they have in common. Most of the numbers I'm going to give you are going to be small enough that you should be able, if you know your times tables, could you figure out that 6 goes into all 3 of these? Is the largest number that will divide into all 3? Yeah. Okay, so 6 is part of the GCF. Now let's look at the variables. A squared, A, and A. What do they have? What's the highest they have in common? Just an A. They all have at least one A. B cubed, B squared, and B. The highest they have in common, they at least have one B in common. So that's going to be my greatest common factor. That's what we're going to factor out. Yes?
So the easier way to do that would be to start with a small number.
Start with a small number.
See if like in your 6 example, see if the largest factor of the small number is.
Exactly. So the smart way is just take the smallest number, look at the factors of the smallest number, say what's the largest factor of the smallest number that goes into all of them.
Yeah.
That's the smart way to save yourself time. So just look at the smallest number and the factors of the smallest number, and then see, okay, which the largest factor of the smallest number that goes into all of them. Okay, so we're going to factor out, because we're actually factoring, we're going to factor out 6AB. We're going to factor out, we're going to pull it out. We're doing opposite of distributive law. Because you can all pull away a 6AB from all of them. So to figure out what goes inside the brackets, we're dividing by that GCF, by each term that was there before. So what's 6A squared B cubed divided by 6AB? What happens with the 6's? They become what, though? 1. So do you have to write a 1? No. A, so A squared divided by A is A. B cubed divided by B? B squared. Plus 24 over 6? 4. A's, what happens with the A's? You reduce out, they become 1. B squared divided by B? B. Okay, negative 12 divided by 6?
2.
Minus 2. And what happens with the A and B? They reduce to 1, yeah. Okay, and so there's our answer. There's factored form. How could we check our answer? Times them all, does it give us our original thing? Okay? All right. So let's go on. We could skip this because we just did it. And go on to practicing a couple more, and then we're done for this lesson. So short and sweet. Determine the greatest common factor. Not very sweet. Okay, let's look at 9 and 12. So the smallest number of these is which one? Smallest number here they give us is 9. Right? Ignore the negative sign. So factors of 9, 1 times 9, 3 times 3. Does 9 go into 12? No, just 3. Yeah, so it's going to be 3. So GCF is 3. And is there any variables they have in common? Just an A. Do they have a B in common? No, not a C. So 3A's are GCF. So that means we're going to factor it out. Pull it out. 9AB divided by 3A. 3B minus 12AC divided by 3A. So because we're factoring it out, we divide each by the GCF to figure out what goes in the brackets. So we could divide both of these by a 3 and an A. And then 12AC, or negative 12AC divided by 3A, 4C. Yeah, so the 3A's are GCF. That's what goes in front. And then in the brackets goes what's left over, the 3B minus 4C. Let's do one more. Joel? What's the smallest number here? Oh, you already got the GCF. The smallest number is 10. The factors of 10 are 1, 2, 5, and 10. So what factor, what's a large, will 10 go into all of those? No? How about 5? Yes, so 5, what else? We have an x squared, xy, xz. What's in 1x? So there's my GCF. Okay. Yes.
There will be a grad council meeting today in the food room at lunch.
Okay.
And also, Miss Brayton Cummings, please come to the office.
Okay. So 5x, where are we going to put the 5x? In front. We're factoring out, then what do we need to put? 5x underneath. Just let's finish this example, guys. Okay. So 5x underneath all of them, and then we're going to divide. 5x squared, don't pack up yet. 5x squared over 5x? 3x minus 2y minus 4z. Now, I'm going to go ahead and finish recording the rest of this. If you would like to stay and get those, otherwise you can go home and finish watching it if you need to. Okay, so your homework tomorrow. All right. Okay, 14, 21, 35. So the smart thing would be to look just at the largest or smallest number is 14. And the factors of 14 are 1 times 14, 2 times 7. So we check. Does 14 go into 21 or 35? That's the largest factor. No, it doesn't. So we go on to the next one, which is the next largest factor of 14 is 7. Will 7 go into 21 and 35? Yes. So we know our GCF is going to have a 7. A squared, A cubed, A squared. What's the largest in common? A squared. They all have at least an A squared. B squared, B squared, B cubed, B squared. So we put the GCF in front, in our brackets. Now you might be able to get to a point where you could just divide that without actually writing it underneath, but if you need to, that's fine, to figure out what goes inside. So 14 divided by 7 is 2. The a squared is reduced to 1. B squared is reduced to 1. Plus 21 over 7 is 3. A cubed divided by a squared is a, and the b squared is reduced to 1. Minus 5. The a squared is reduced to 1. B cubed divided by b squared is b. And there shouldn't be like terms inside, because if there are like terms inside, that means there were like terms ahead of time that we didn't collect. So usually there won't be. Okay. So this guy, 2 pi r squared plus 2 pi r h. What's in common? Greatest common factor. Do we really have to go through looking at the factors of 2? Or what can we divide both of those by? 2. Also, they have pi in common, 1 pi, and what else? And r in common, 2 pi r. So we're going to factor out 2 pi r. It's actually a formula for the surface area of a cone. No, cylinder. Divide both by 2 pi r, and we're left with kind of a cool formula. 2 is reduced to 1, pi is reduced to 1, so we just have r plus h. There you go. Okay, the last one. Now this one's really tough because we haven't dealt with a fraction before. So we want to actually change them to both into fractions with the same denominator. So can we change negative 4 into a fraction with a denominator of 3? What divided by 3 is equal to 4? 12. Yeah. So we're going to write this as 12 over 3 minus 12 over 3 pi r squared. Now this type of factoring is tough when you have fractions, and you use it mostly in calculus, a lot actually. So how do we factor something like that? Looking at the numerator first, 4 and 12. What can we divide 4 and 12 both by? 4. We can pull out a 4 out of both. And then we can also pull out of the 3 out of the denominator. So we're factoring out 4/3. So our GCF, 4/3, what else do they have in common? Pi and r squared. 4/3 pi r squared. Okay, so 4/3 pi r cubed divided by 4/3 pi r squared. What's the only thing that's left? We pull out 4/3, we pulled out the pi, we just have an r. Now, remember we factored from the numerator 4 out of the 12. So what's 12 divided by 4? 3, and we already factored out the 1/3, the denominator. Because if we divide 12/3 by 4/3, it's the same thing as multiplying by 3/4, 12/3 pi, right? So it's really 12 divided by 4. We're factoring out that 4, which just gives us 3. So the number would be minus 3, and we factored out pi r squared. Would there be anything left over? No. Both the pi and the r squared cancel out. Okay, so then the inside is just r minus 3. That's a really tough question. I probably wouldn't give that to you. I wanted to show you an example of the fraction. Probably wouldn't give that to you on your test. And then there's the homework for this lesson. Okay? Thanks, girls. Staying.